All right, number 4 on problem set 1 has to do with a double replacement reaction. I threw in this question because it deals with molarity and volume, which is always good to refresh how to solve molarity type questions. Okay, so it says a 0.15 gram sample of lead 2 nitrate. I'm going to write that in. Nitrate's a -1. Lead is a 2 plus. A 0.15 gram sample of lead 2 nitrate is added to 125 milliliters of a 0.1 molar sodium iodide solution. Assume no change in volume of the solution. So we need to write the chemical reaction. So it said it's solid, so we should probably put solid. But I'm adding it to a solution. It'll probably dissolve. Okay, double replacement reaction. The lead is going to go with the iodine. It's still 2 plus, and iodine is still 2 minus. And then the sodium is going to go with the nitrate. I want you to pause this video and reference your solubility rules from the summer packet. You will need to memorize these for AP Chemistry. What you should know is that all nitrates and alkali metals are aqueous. Always, always, always. They will not form a solid. What you should also see are chlorides and bromides and iodides are normally aqueous unless it's bound to mercury, lead, or silver, thus making it a solid. So when it's insoluble, this guy is typically soluble unless it's paired with lead, mercury, or silver. It would make it insoluble, which means it's a solid. So that's it for here, except for I need to balance. Good. It says, list an appropriate observation that provides evidence of a chemical reaction between the two compounds. So the only way that a double replacement reaction can actually occur is if you form some state of matter, and here we're going to form a solid. That solid is called a precipitate, and this one just happens to be yellow. You didn't get docked points if you didn't know it was yellow. You just had to say a precipitate would form. Calculate the moles of each reactant. Okay, so we have a 0.150 gram sample of lead 2 nitrate. That's one reactant. And the other reactant is 125 milliliters, or 0.125 liters, of 0.1 molar sodium iodide. So if we're trying to get moles, going from grams to moles is easy. You just find the molar mass. Going from volume to moles is a little more tricky, but it's not if they give you the concentration. This 0.1 molar solution means you have 0.1 moles in 1 liter of solution. It doesn't matter if you have 1 liter or not. If you had 1 liter, there would be 0.1 moles of sodium iodide in it. But we only have 0.125 liters, or 125 milliliters. So I convert this to liters, and I said for every 1 liter of sodium iodide, you will have 0.1 moles of sodium iodide. And now your units of liters would cancel, and you'll get moles. So 0.125 times 0.1 is 0.0125 moles. That's it. Sometimes people get all tripped up about molarity, but as long as you rewrite molarity as whatever moles they give you per 1 liter, it will always, always, always be out of 1 liter. You can solve any stoichiometry problem. Just start with the volume they give you, use the molarity fraction, and then solve. For lead 2 nitrate, it's simple. You just look up the molar mass on the periodic table. I got 331.22 grams in 1 mole. So for this, I got 4.53 times 10 to the -4th moles of lead 2 nitrate. All right, that was it for that one. So identify the limiting reactant and show a calculation to support your answer. So I'm going to solve for a product, and it doesn't matter how you sit at the problem as long as you solve for the number of moles or grams of this product using the 2 starting points, then you can solve for a limiting reactant problem. So starting with my 4.53 times 10 to the -4th moles of one reactant, I want to figure out how many moles of product I'm going to make. And then starting off with the solved 0.0125 moles of my other reactant, I'm going to see how much product I can make. According to my balanced chemical equation, for every 1 mole of lead-2 nitrate, I form 1 mole of lead-2 iodide. So that's easy math. But I'll plug it in just to show you. So it's the same, 4.53 times 10 to the negative 4th moles. Oops, PbI2. And now I'm going to do the same thing with sodium iodide. Only got to check my mole ratios. For every 2 moles of sodium iodide, I produce 1 mole of a product. So now I'll put that in my denominator. For every 2 moles of sodium iodide, I only produce 1 mole of my product, according to my balanced chemical equation. So 0.015 divided by 2 is 6.25 times 10 to the negative 3rd moles of PbI2. So, because this number is smaller than this number, this is the maximum amount of product I can make, which means lead-2 nitrate is limiting my product amount. So once all of this is used up, I cannot make any more of lead-2 iodide. So lead-2 nitrate is my limiting reactant, LR. Okay?